This is the Chapter 6 test review. Test will be Thursday. First problem. X cubed y squared to the negative 1. We could do a couple of ways. We could go ahead and distribute the negative 1. And then remember what the negative means. So x to the negative 3 is 1 over x cubed. And y to the negative 2 is 1 over y squared. So this would be 1 over x cubed y squared. Another way you could look at doing this is going ahead and applying the negative initially and flipping everything right off the bat. Get the same thing. All right. Second problem. X cubed y cubed divided by x to the negative 2 y to the negative 2. Again, one way I could handle this problem is look at my x's. I have the same base. When I divide exponents with the same base, I subtract them. So 3 minus negative 2 is 5. And 3 minus negative 2 again is 5. Another way I could have done it is remember that negative means flip. So this would be times x squared, y squared. And then when I multiply with exponents in the same base, I add. So 3 plus 2 is 5. And 3 plus 2 is 5. Get the same answer. All right. Next problem. Looking at this, I know the negative means flip. So I'm going to move the xy to the numerator and then raise it to the positive 3. So this becomes x cubed y cubed. Okay, number 4. I would probably on this one simplify each fraction together and then multiply what you've got simplified. So in the first fraction, I don't have any other x's, so that's just going to be x squared. The second one, I have y cubed and y to the negative 4. Remember, you subtract exponents, so it's 3 minus negative 4, so that becomes y to the 7th. And then I'm multiplying that by this next one simplified. Again, I can't do anything with the x to the negative 2, but I do know that negative means flip. So I'm going to go ahead and move that to the top. And now I'm going to focus on the y's. I have 4 minus negative 3, which again is y to the 7th. So now I have x squared y to the 7th times x squared y to the 7th. Looking at my common bases, my x's, I add the exponents. And looking at my y's, I add the exponents. And there's my answer. Okay, this problem says describe the end behavior of the graph of the polynomial function, then evaluate it at negative 2, negative 1, 0, 1, and 2, and then graph that using those 5 points. So when I look at this function, the leading term is what I evaluate for end behavior. If the number or the degree of this function, which you find by looking at the leading term, is odd, the end behavior looks like the line y equals x. Because y equals x, x is to the 1, right? And 1 is odd. So all odd functions are going to have this end behavior. It may have other things going on in the middle, but ultimately the end behavior of the function will have this. So an odd degree function, I would write the end behavior this way. As x approaches positive infinity, y approaches, well, as x gets bigger and bigger and bigger, y is getting bigger and bigger and bigger. So y is approaching positive infinity. As x approaches negative infinity, okay, y is approaching, well, it's getting smaller and smaller and smaller, so negative infinity. That's how you write end behavior for an odd function. No matter what the degree, if it's odd, that's how the end behavior is written. If it's x cubed, x to the 5th, x to the 7th, and so on, this is how you write the end behavior. Okay, now looking at the second part, evaluate the function at these various values of x. So negative 2, that becomes negative 8, minus negative 2 squared is positive 4, minus 4 times negative 2 is negative 8, so that becomes plus 8, plus 4. Well, that all cancels. So at negative 2, y is 0. Because negative 8 plus 8, negative 4 plus 4. Okay, negative 1. Negative 1 cubed is negative 1. negative 1 squared is positive 1. Negative 4 times negative 1 is positive 4 and plus 4. So this is negative 2 plus 8, which gives me 6. Evaluating at 0, and that's 4. It's the y-intercept. Evaluating at 1, I have 1 minus 1 minus 4 plus 4. So that is 0. 1, 0. And evaluating at 2. 2 cubed is 8 minus 2 squared, which is 4, minus 4 times 2, which is 8, plus 4. That's also 0. Okay, now I have 5 points. I can then graph. So at negative 2, I have 0. At negative 1, it's 6. At 0, it's 4. At 1, it's 0. And at 2, it's 0. Okay, I know the end behavior is going to shoot off this way and this way, because that's what I found out. As x approaches positive infinity, y approaches positive infinity, and as x approaches negative infinity, y approaches negative infinity. So once I find those end zeros, I know after that it's going to shoot in that direction. So now it's just a matter of kind of finishing the curve, and that really should look like that. And this could go up like this. Okay. The only thing I really don't know for sure is how far down this goes, but this is just a sketch, and as long as I'm going through all those points and I understand the end behavior, this is going to be close enough. All right, let's do the same thing now for the next one. This time, this is if I were to FOIL it, which I don't need to do this problem, but if I were, it's x squared times x times x. So that's an x to the 4th would be my leading term. So it's an even degree. And for an even degree, even degrees will always look like an x squared. Because x squared's even, x to the 4th is going to have exactly the same end behavior. There may be other things going on in between, but it's going to shoot off the same way at the end. So as x approaches positive infinity, y approaches positive infinity. So that's true. As x approaches negative infinity, y is getting bigger. So there's the difference. Okay, so this is how you're going to write end behavior for any even function. X squared, x to the 4th, x to the 6th, and so on. Now I'm going to go ahead and do the negative 2, negative 1, 0, 1, and 2. And when I put negative 2 in, I have negative 2 plus 1, that's negative 1. Negative 2 minus 2, that's negative 4. And negative 2 squared is 4 minus 3 is 1. So negative 4 times negative 1 times 1 is just 4. Do the same thing with negative 1. Negative 1 plus 1 is 0. Don't even have to go anymore, because 0 times anything will be 0. 0. Well, I have 1, negative 2, negative 3. So that's 6. At 1, I have 2, negative 1, and 1 minus 3 is negative 2. So that's what? Negative 4 times negative 1, which is positive 4. And then at 2, 2 plus 1 is 3. 2 minus 2 is 0. So I'm back to 0. So now I've got enough to go ahead and sketch this. Negative 2, 4. Negative 1, 0. 0, 6. 1, 4. And 2, 0. Now I'm remembering the end behavior is going to be in this direction on both ends. Okay? So what I really don't know is how far is this going to bounce off of the x-axis? I don't know. I'd have to just graph it on a graphing calculator to see. But my guess is it's going to have this shape in some manner. All right. Next one, perform the indicated operations. The thing you really have to be careful here, and I've seen this several times, if you choose to use a separate piece of paper for these kinds of problems to record your answers, write them exactly the way this is written. I had a student write this on their paper and not put the negative, and so they ended up multiplying everything. Make sure that you're copying these problems onto your paper exactly the way the test is written, because this is a subtraction problem, not a multiplication problem. And the easiest way to tackle a subtraction problem is to go ahead and distribute that -1 to every term and then make it an addition problem. So I'm going to go ahead and do that. I'm going to write the first expression exactly the way it's written. I don't need the parentheses anymore because I'm going to handle this negative distribution and it's going to become an addition problem. So negative 5x cubed plus 3x squared minus x plus 4. Now I'm just going to combine all my like terms. I have a 4x cubed and negative 5x cubed. That's negative x cubed. I'm going to cancel as I go. 3x squared plus 3x squared is 6x squared. Negative x minus x is negative 2x. And 2 plus 4 is 6. And there it is. All right, next problem. Before I can multiply these together, I have to apply the exponents. Remember, exponents come before multiplication. Okay, so I know I've got this xy plus 4. I'm going to handle that later. I'm going to handle this xy minus 3 squared. Remember the shortcut. To square a binomial, you square the first term. And remember, if I'm going to apply the 2 to both of these variables, both variables get squared. You square the last term. And the middle term, because remember there's always a middle term, is this term times 2. So negative 3 times xy times 2 is negative 6xy. Now, if you can't remember that, all you need to do is FOIL. Okay, xy times xy is xy squared. xy times negative 3 is negative 3xy. xy times negative 3 is negative 3xy. When I add those two together, I get negative 6xy. And negative 3 times negative 3 is 9. Okay, now I'm going to go ahead and multiply this by xy plus 4. Okay, x squared times xy is x cubed y cubed. X squared y squared times 4 is 4x squared y squared. Negative 6xy times xy is negative 6x squared y squared. Negative 6xy times 4 is negative 24xy. 9 times xy is 9xy. And 9 times 4 is 36. And then I just combine my like terms. I don't have any other x cubed, y cubes. These two are like, so that's negative 2x squared y squared. These two are like, so negative 24 plus 9 is 15, negative 15xy, and plus 36. And there it is. All right, next problem. Same thing, I'm going to FOIL. What I might do is go ahead and distribute this one first. Xy squared times x squared is x cubed y squared. Xy squared times xy is x squared y cubed. Xy squared times y squared is xy to the 4th. And then I'm going to multiply that by 2x plus y. And again, x cubed y squared times 2x is 2x to the 4th y squared. X cubed y squared times y is x cubed y cubed. X squared y cubed times 2x is 2x cubed y cubed. X squared y cubed times y is x squared y to the 4th. Xy to the 4th times 2x is 2x squared y to the 4th. And xy to the 4th times y is xy to the 5th. So I'm going to look and see. I don't have any others with this as a term. I have an x cubed y cubed here and here, so that's 3x cubed y cubes. And then I have an x squared y to the 4th here and here, so that's 3x squared y to the 4ths. And then I have a xy to the 5th. And that's it. All right. Factor the polynomial completely. This first one is just a difference of two squares. So when I have a difference of two squares, I take the square root of both, and I write them twice. One with a plus, one with a minus. And then I would look and see, actually with this one, I think the best way to go here is to factor the common factor first. And then look at this as difference of two squares. 2x minus y, 2x plus y. Just the square root of this term and the square root of this term. Okay. Next, I see a cube on the y, so I'm thinking that eventually I may be doing a sum of two cubes. But in order to get a perfect cube, I've got to factor a 2 out. So now this is a perfect cube and this is a perfect cube. A is the cubed root of the first term, which is 3y. B is the cubed root of the second, which is 1. Then I use my formula, 3y plus 1. Then I square 3y, and be careful because when you square 3y, both terms are squared. Okay? Then I subtract 3y, just this times this, and then I add the square of 1, which is just 1. And I'm done. There's no other factoring I can do. Next one, I just need to factor the common factor out of all terms first, and it looks like it's going to be 3x y cubed. Then I look at the first term. If I take a 3xy, there's no y cubed here. If I look at the first term and I take a 3 out of the 6, I'm left with a 2. If I take an x out of the x cubed, I'm left with x squared. And I take a y out of the y is gone. Next, if I take a 3 out, I'm left with 1. An x out, I'm left with x. A y out, I'm left with y. And then here, if I take a 3 out, I'm left with 6. An x out, there's no x left. And a y out, it's y squared. Now, I need to check and see whether this is factorable. So if I look and do bottoms up, right, multiply this term by this term, is there when I'm looking just at the 12, can I do any combination of factors of 12 that would add up to 1, looking at this coefficient? So 4 and 3. X plus 4, and this would have to be 4y, and x minus 3y. And I could check it. X squared minus 3xy plus 4xy is plus 1xy, and then minus 12y squared. And then I can't forget the 3xy on the side. So what we learn with quadratics will work when you've got something a little more complicated like this one. But make sure when you get down to this point that you try and factor it before you just stop. All right. Next problem is a solve problem. So I'm just going to divide both sides by 2 and then take the square root of both sides. And that's it. Here, I need to get everything to one side. And I'm going to go ahead and put the minus 4y to the 4th first, just so that I have it in decreasing order, set it equal to 0. Now I'm going to pull out what's common to all three. I always want my leading term when after I factor it to be positive, so I'm going to pull a negative 4 out, and then I'm going to have y to the 4th. And if I pull a negative 4 out here, it's going to be negative, and it really needs to be negative 4y squared, doesn't it? Because there's a y squared common to each. So there's a y squared. When I pull a negative 4 out of this, it's negative 4y. And when I pull a negative 4 out of this, it's negative 12. And that's it. Now I'm going to look again and see, looks like 6 and 2 might work here. So y minus 6, y plus 2. And in fact, that does factor to this. And then I've just still got the 4y squared on the outside. So there it is, fully factored. I was trying to solve. So now I know this term equals 0, so y equals 0. I know this factor, y is equal to 6, and I know when this is factored, y is equal to negative 2. Now, if this was equal to 0 and you needed to solve and you didn't recognize you could factor this, you could always use the quadratic formula. All right, next one. To solve this one, I think what I'm going to do is go ahead and FOIL this, so I get 4x to the fourth plus, remember when it's a squared binomial, this times 2, 12x squared plus 9 equals, and go ahead and distribute, 4x to the fourth plus 24x. Now I'm going to move everything to one side and set it equal to 0. Well, I can see already when I subtract 4x to the fourth from both sides, that goes away. So I'm going to end up with 12x squared minus 24x plus 9 equals 0. I see that 3 is a factor to all. And then I'm going to look and see if I can factor this. 4 times 3 is 12, so if I use the bottoms up, both of them have to be the same sign for this to be positive. So again, it's going to be 6 and 2, but this time they're both going to be negative. If I use the bottoms up, I've got to divide by 4. And now that I'm thinking that, I think I forgot on that last problem that I used the bottoms up for to divide by that coefficient I multiplied by. An easy mistake that I see you make too, so it's not just you. But go back to that part of the video, I can't remember which problem it was, and make sure when you're factoring it that then you go back and divide by the coefficient like this. Simplify x minus 3 halves, x minus 1 half. And then I still have this 3 on the outside, which really isn't going to matter much, because when I set it equal to 0 and divide both sides by 3, that goes away. So my solutions here are 3 halves and 1 half. Sorry about that last problem when I did the bottoms up incorrectly. All right. Use synthetic division if possible. So it's definitely possible here. Remember, if they give you a factor, the number you're going to use is 3, not negative 3. And I'm going to divide it into 1, negative 2, must be a placeholder for the x, and negative 9. 1, 3. Remember, just bring this down. Don't do anything else. Add these together, multiply by 3. Add these together, multiply by 3. There's my remainder. So when I divide it, what I have left is x squared plus x plus 3. That's the answer. Okay, the next one, I'm going to use 3 again. And again, I'm going to do 1, 0 for the x cubed, negative 10, 2, and 3. Bring my 1 down, times 3. 3 times 3 is 9. Negative 1 times 3 is negative 3. Negative 3 plus 2 is negative 1. Negative 1 times 3 is negative 3, and 0. So what I have left here, x cubed plus 3x, 3x squared minus x minus 1. Okay, this one just says possible. I don't have to, oh, then it does say find all the zeros. So possible, plus or minus 1 in the numerator, plus or minus 1 and plus or minus 2 in the denominator. I'm not done. My possibles are plus or minus 1 or plus or minus 1 half. I must rewrite them in order like this. Not necessarily in order, but don't just stop here. Write them as a list. Now, I'm going to use this to find the actuals. So if I start, I could do it one of 2 ways. I'm going to go ahead and just go to the graphing calculator and go to y equals, clear whatever's in there. Just type in 2x cubed plus x squared plus 2x plus 1. And make sure that when you're doing this that you come down with your exponents, which I did not, plus x squared plus 2x plus 1. Graph it. Looks to me like maybe, that's hard to see. I need to zoom out or go to standard in my window. Looks to me like it's at 1 half. Is that right? I don't know. I think I'll just start with 1. Okay, so I have 2, 1, 2, and 1. Write these down over here. 2, 1, 2, and 1. 2 times 1 is 2. 3 times 1 is 3. That's not going to work. Let's try the negative 1 half that it kind of looks like here. 2 times negative 1 half is negative 1. that's 0, that's 0, 2, negative 1, there it is. So I end up with 2x squared plus 2 equals 0. Now to solve, I subtract 2, so I have 2x squared equals negative 2, divide by 2, x squared equals negative 1, take the square root of both sides, x equals plus or minus I. The square root of negative 1 is I. So plus or minus I. So my all zeros, I have to do both real and imaginary. It's going to be negative 1/2 and plus or minus I. Okay, next one. Same deal. Plus or minus 1, 2, 3, 4, 6, and 12. And fortunately, there's no denominator because 1 is the leading coefficient. I'm going to clear this out. X cubed plus 2x squared minus 11x minus 12. And graph it. It looks to me like it is negative 3, negative 1, and 3. Okay, so now I'm just going to start with one of the zeros, which is negative 1. So I'm going to do 1, 2, negative 11, negative 12. If this works, I do it correctly, I should get a 0 remainder. 1, negative 1, 1, negative 1, negative 12, positive 12, there it is. I really only need to do it one time because what I have left is x squared plus x minus 12 equals 0. Factor it, plus 4, x minus 3. So I wasn't quite right when I read that. It's actually going to be negative 1, negative positive 3, and negative 4. Those are my real zeros. Okay. These next two, if I want to write this as factors, I do that. And it tells me my leading coefficient is 1, so I don't have to, normally we put an A here and then we need a point. But when they tell me it's 1, I don't have to worry about it. So now I'm just going to FOIL. X squared plus 2x plus x is plus 3x plus 3. And I'm going to multiply that times x plus 3. X squared times x is x cubed. X squared times 3 is 3x squared. 3x times x is 3x squared. 3x times 3 is 9x. 3 times x is 3x, and 3 times 3 is 9. Combine my like terms. And this is the polynomial that if I were to find the zeros, I would figure that the zeros are this. Okay. Remember, I am going fast through this. You should pause it, write the problem down, try it yourself, then watch me do the work and see if we get the same answer. And if not, figure out where the disconnect is for yourself. Next, I've got 3 zeros given, but remember, anytime I have an I or a root, I always know that the conjugate is also a 0. So to write this as factors, x minus 3, x plus 3, x minus 2i, x plus 2i, and now FOIL. This is x squared minus 9 because it's a difference of 2 squares. This is x squared minus 2i times positive 2i is negative 4i squared, which is plus 4. Now I can just FOIL this. X to the 4th plus 4x squared minus 9x squared is minus 5x squared. Minus 9 times 4 is 36. And this is the polynomial that would give me these 4 zeros, even though there's only 3 written. All right. Use a graphing calculator to approximate the real zeros. So I'm just going to type this in the graphing calculator. 0.2 x cubed minus 2 x squared x cubed minus 2 x squared minus or plus 6. And graph it. And then I just use the 0 function to find the minimum or find the zeros. So it looks like 1 0 is at negative 1.61. Another 0 is is at 1.93, and then another one, I just go to the last zero here. And that is 9.68. Okay. Identify the x-intercepts, local maximum, local minimum of this graph. Well, the x-intercepts are at 4 and -4. I can see that because it's an intercept form. To find the max-min, again, I'm just going to plug in this whole thing, x minus 4 quantity squared minus 4 squared, okay, times x plus 4 squared. That's 4 squared. Graph it. And then I'm going to use the max min. The min looks like it's happening at y equals 0, both of these zeros. And the max, I have to get it in my window, and when I do, and use the second calc and then the max button, it's going to be 16. The end behavior, because it's an even function, 2 times 2 is 4, the end behavior is going to be as x goes to positive infinity, y goes to positive infinity, and as x goes to negative infinity, y goes to positive infinity. Find all the zeros of the function. I put the ones in just because I wanted you to do the work and not just give you multiple choice answers that you could plug in. So what I'm going to do first is go ahead and graph it. X cubed minus 15x squared plus 73x plus 111. Minus 15x squared plus 73x plus or minus 11. And I'm going to hope that I have one real that I can use here. Zoom. I've got to get it in my window here. Delete. And 2. Okay. I'm not seeing any. There must be another zero way out that's a real number. I'm going to zoom out on my x's. Let's see if I can see the graph coming back down. I really don't. X cubed, I may have put it in wrong. X cubed minus 15x squared plus 73x minus 111. 111, I put 11 in. There's my problem. Zoom, standard. Looks like 3. So I'm going to use 3 with synthetic division. 1, negative 15, 73, and negative 111. 1, 3, negative 12, negative 36. 73 minus 36, just to get going here. 37 times 3 is 111. So there it is. So then I'm left with x squared minus 12x plus 37. Because it didn't appear on my graph that there were any other zeros, I know this is going to be an irrational or possibly even an imaginary. So I'm going to use the quadratic formula. 12 plus or minus the square root of 144, which is 12 squared, minus 4 times 1 times 37, all over 2 times 1 is 2. 144 minus 37 times 4, yep, is going to be 12 plus or minus the square root of negative 4, all over 2. So that's 12 plus or minus 2i all over 2, which is 6 plus or minus I. So my zeros are 3 and 6 plus or minus I. Okay. For the sake of time, I'm going to do one of these with polynomial long division, because the other will be the same process. The biggest thing to remember is you need to put placeholders if they don't go in consecutive exponent order, which is what I just didn't do. plus 0x minus 4. X cubed times 6x squared is 6x to the 4th plus 18x squared, and that's changed my sign. So I get 0x cubed, which I don't even need to write, 2x squared plus 0x minus 4, x squared times 2, and minus 6 when I change my sign, so that's minus 10. So my remainder is 10. My answer is 6x squared plus 2 with a remainder of negative 10. And that's it. All right. I'll get this posted right now, and you should have all day today. This is Wednesday morning to review it.